Alright, hello everybody. So today I'm going to talk to you about types of reactions and also some tricks that you can use on the reference tables to figure out if a reaction actually occurs. So first we're going to talk about the types of reactions, and there are four main types of inorganic reactions that you need to know. The first kind is called a synthesis. So this is a synthesis. Sometimes the synthesis is also called a composition reaction. And the way that they show it in the textbook and illustrate this is that you have two elements coming together, A plus B, and they will form a compound AB. In real life, this would be two different elements, like you would have, H2 and O2, and then they would form H2O. And you can balance that because you should know how to do that. So this is a synthesis reaction. The next type of reaction is the opposite of a synthesis. It is a decomposition reaction. And that's why I told you that a synthesis is sometimes called a composition, because it's the opposite of a decomposition. Decomposition would be where you have this compound and it breaks down into its components. You could also have something where you have a partial decomposition, something that's a larger compound breaking down into smaller compounds, and that's a partial decomposition, but it's still a decomposition nonetheless. And so an example of this one on the left here would be if we were to have something like NaCl and we were to make that into NaNCl. A partial decomposition would be if we were to have something like NaClO3, and that would break down into NaCl and O2. And again, these are nice to practice balancing. You could practice balancing them, and we could talk about how they were balanced tomorrow. So here's synthesis and decomposition. The next type of reaction is called a single replacement reaction. So a single replacement reaction is where you have an element and a compound, and then you switch. Depending on the charges, I'll show you two types, something called a cationic and an anionic single replacement. But here we'll just switch the A and the B, so we would have AC plus B. And so you could have something where you have, where you could have copper plus, actually let's do aluminum plus copper chloride. It's a great reaction to do. I'll have to demo this for you. Now I see that there's two metals here. I have the aluminum and I have the copper metal. And so those metals will switch places because in a compound, both of them are positive ions. If you look here, the Al starts off as an element. It doesn't have any charge to it. But then with the copper's in the compound is +2. The aluminum will take its place as a positive ion, and the copper will be displaced. And this is a cationic exchange. Cationic meaning the positive ion is replaced. You could have something where you have a halogen replacing another halogen. That's an anionic, and that would be something like if I were to have F2 plus NaCl, and now the F and the Cl will replace each other, and we'll be left with NaF and Cl2. Now the last type of reaction is called a double replacement reaction. And a double replacement reaction is where you have two compounds. So you'd have, for example, AB plus CD, and now the positive ions A and C will replace each other, so you'll be left with CB plus AD. And this would be an example where you would have two compounds, like, for example, if we were to have barium chloride plus silver nitrate. In the end, you would end up with barium nitrate and silver chloride. So we have our two reactants, our compounds, our two products, our compounds. So look, you need to memorize these types of reactions, and you need to be able to, recognize them, and we'll practice recognizing them in class, and then you also need to be able to balance them. Now something that we do in honors, and if you're interested in taking the SAT, you'll have to memorize this chart down here, but a lot of times these double replacement reactions happen in solution. And so if I take this example up here that I had, if I copy this and I paste it down here, and I move my Cl up here, if I take this reaction up here, these first two starting materials have phases that are in aqueous solution. So these are aqueous. They're floating around in water. So I have my two aqueous solutions. Those ions are really separated in the solution, and they can recombine into new compounds. The compounds that they recombine into are barium nitrate, which is aqueous, and solid AgCl. It's the formation of this solid here, which is called a precipitate. So it's the formation of that precipitate, that solid that forms. That's what's called driving the reaction. If no solid forms, no reaction will happen. And you have to be able to use this table F that comes from the reference tables in order to predict if a solid will form. Because if a solid doesn't form, the reaction won't occur. So how do I use this table to see that AgCl is in fact a solid? And so the terms that they use are here. If we look at table F and dissect it, the title of each column here is soluble, and soluble means that it is aqueous, or an exception to soluble, which would make it insoluble, which would mean it's a solid. Likewise, over here, the column up here says ions that are insoluble, meaning that they form a solid. And the exceptions would make it soluble, or aqueous. So how does this work? Well, let's look at our two products here. I'll highlight both products. Let's look at barium nitrate. The two ions there are barium, Ba, and nitrate, NO3. Let's see if I can find them in the first column here. Group 1, NH4, here it is, nitrate. The chart tells me that nitrate is soluble, meaning that it will dissolve in the water. And there are no exceptions to it. That means that any ion, barium or otherwise, combined with the nitrate will be soluble. And that is why I put the aqueous there. Now let's see if we can find Ag or Cl. So we go through the chart and we look for Ag and Cl, and I see down here, here's Cl. Well, Cl is soluble too. But there are exceptions. The exceptions include Ag. Well, wait a second, I have Ag right here. Ag is an exception to that rule. So Ag, when combined with Cl, just like it is in my compound here, will become insoluble. It will be a solid. They call it a precipitate because it happens very quickly. If you mix these two chemicals together, very quickly you'll get this silver chloride precipitate that forms. So go ahead and try another one, and let's see if you can predict if a reaction will form a precipitate or not. Let's try something like barium nitrate reacts with sodium chromate. So what I'd like you to do is I'd like you to actually go through and write the products and tell me if either of them are solid using the chart above, and using that chart above will the reaction occur. Okay, the last table that I want to talk to you about is helping to predict if single replacement reactions occur. So this chart is helped to predict if a single replacement reaction will occur. So let's take the reaction I did before. Aluminum plus copper chloride yields aluminum chloride plus copper. What I'm looking for is on the chart over here for the most active element to be uncombined. So what I'm looking for, and I'll write this, so I'm looking for most active element to be uncombined, not in a compound. So let's take a look at this. So if I look here, I see that I look for aluminum and aluminum is right here. And I look for copper, and copper's down here. Aluminum is uncombined. It's not in a compound. And it is most active. It's higher up. This reaction will occur. What the chart's saying is that because aluminum's more active, it will replace the copper. And that's exactly what happens. Let's look at the other example we did. We did F2 plus NaCl yields NaF plus Cl2. So now the elements replacing each other are the F and the Cl. And I look for them here. Here's F, here's Cl. Well, F is higher up. F is more reactive. F will replace Cl. So we're always looking for the most active element to be uncombined and replace the least active element. So, here's one for you. Tell me if this will actually occur. So let's do some zinc plus HCl yields zinc chloride plus H2. So figure out what's replacing what, and then from there, see which one is higher up, see if the reaction will occur. All right, thanks so much for watching. We'll talk about this soon, and I hope you have a great day.